This video is about the Starrett 221 high precision micrometer, which is unique in that it has two thimbles. This is the inner thimble, which is graduated in 1/1000th of an inch like a normal micrometer, and then this is the outer thimble, which is graduated in 10,000ths of an inch. And as you can see, when I move this from 0 to 0, you can see this changes by 1,000. It was patented in 1941 by A.G. Hagstrom, and I first saw it in Starrett's 1955 catalog for $32.75. The 2016 cost is $575. Starrett engineers requested Hagstrom to make changes to his original design to automatically compensate for several wear points. He did and received another patent in 1956 for the changes. This second patent is the number on the back of the micrometer. The fine thimble here is spring loaded so that when you go from 0 to the next 0, you put the exact same tension on the spindle here each time. But make sure you don't let it spring back, or if you do over a period of time, it will damage the micrometer. Just use your finger pressure. The 0 mark on the outer thimble will always return to the horizontal measuring line. If it doesn't, then there's a problem with the micrometer. Before I do a measurement, I clean the faces with a piece of laser printer paper because it has practically no dust. I'll also recheck the 0 setting to make sure it hasn't changed. I use, if I'm making critical checks, I use or doing a calibration or checking calibration, I use a micrometer holder to keep the heat. If I were to hold it with my fingers, the heat would tend to cause this to expand or contract. I also clean the gauge block before I use it. In this case, I'll be using a 0.1002 gauge block, which is a Starrett crow block in grade 0. These are extremely stable and hard. The gauge block is calibrated at 68 degrees. And my room is at 80 degrees, so using Starrett's coefficient of thermal expansion equation for crow block, which is 4.75 millionths of an inch, times the gauge block length, which in this case is 0.1002, and times 12 degrees, which is the change in degrees. In this case, it would come out to, it would add 6 millionths of an inch to the length of the gauge block, which with this micrometer is not significant. So I put it in and torque down to 0, release it, and as you can see, each one of these divisions is 25 thousandths, and I made it's 4 divisions of 25 thousandths each, so that's 100 thousandths, or 0.1, and as you can see, it is slightly over 0.1, and we know it's going to be, it should be 2 10,000ths. So now to get an accurate reading, we move the outer thimble until the inner thimble lines up on 0. I usually rock it back and forth a few times, and you can see here it's exactly 2 10,000ths, which is what we expected. If I go to 1 10,000th, it's slightly under. If I go to 3 10,000ths, it's slightly over. So that checks out good. So you would add 2 10,000ths to this figure, which would be 0.1002. Now we'll check the a 1-inch block. This is also a Starrett crow block, and it is also grade 0. Taking into account the coefficient of thermal expansion, this 1-inch block should be 1/2 10,000ths over 1 inch. So I'll go up to a little bit over 1 inch. Set the pressure, let it back, and as you can see here, it is very slightly over 1 inch. So I use my 10,000th thimble, and I'll rock it back and forth a few times, and I'll land exactly, and as you can see, it's exactly 1/2 10,000th. If I go to 1 10,000th, you can see it's just ever so slightly over. Again, I'll rock it back and forth, and it's exactly 1/2, which is 50 millionths of an inch. So it checks out okay. Starrett states that the accuracy is 50 millionths of an inch, which checks out here. And in the hands of a experienced machinist, you can split this up into parts also. Probably somebody with a real good eye, better than mine, could probably get maybe 20 millionths. They could probably split that up into 5 parts, which would be 20 millionths of an inch. On a new micrometer, you'll notice this shiny part. On a new micrometer, this won't be shiny. It'll be the same color as this. This sleeve is used as a bearing surface for the inner thimble. Starrett states that this is normal and will not affect the accuracy, the long-term accuracy. And this, I bought this micrometer used, and it was well used because it was shiny like this. This micrometer could be 20 or 30 or maybe 40 years old, and it's still perfectly accurate. I collect micrometers, and this one is my favorite. If you have SketchUp, which is a free 3D CAD program, you can download a 3D drawing of the 221 from 3D Warehouse, which is where SketchUp stores its pre-drawn models that people submit. It'll show the complete micrometer in three-dimensional, and I also broke out the individual parts to show those, and it is drawn in very high detail. This is a housing, and that's where the spring is, the tension spring is located. A very nice, high precision piece of test equipment. I hope you enjoyed.